Okay, welcome back to the CNPS 2018 conference, Storrs, Connecticut, University of Connecticut. I'm going to talk now about the physics. Is the big issue. And in fact, David mentioned this. People ask him, how do they connect to science? And one of the things that I realized that would help us is if we could organize this. And we went through 2 years figuring out ways to do this. So the forum was one of the ones that worked. And what's the key to understanding the forum is it takes the knowledge that we are discussing and just puts it in an organized outline. Simple as an outline could be, it has the same structure as the alphabet has for organizing knowledge. And the alphabet just seems like nothing, A, B, C, D, E, F. But when you realize how much of the world is organized around that simple tool, that's what the forum tries to do. He expected help from CNPS was publishing his papers. So I said, exactly. So let's talk about how to do that. And when I changed his view from how he was going to publish his own paper to thinking about how to help all the members publish their papers, he said, okay, he'll dig into it a little and review it. And he went to the database and he came back and said, we have a problem. I said, what's that? He says, there's 10,000 papers. What are we going to do with all these papers? We've been so good at cataloging and organizing and getting them all together, but there's masses of them. So we have to figure out how to focus this problem. That's what the forum was trying to do, is structure things. So when David was pointing out about if you want to go on as a member and have your own homepage, you're going to have to put in and get more detail involved. That's the same thing we started to do with the papers. So Lloyd said he would work on this, and he worked on this for over a year. By looking at our emails and the time he worked, he put over 200 hours last year in working on this problem as a member. That's dedication. And what I've tried to do is get that kind of dedication from other members and focus it. So what he was able to do is get members to produce the list, and he published it, and he got different communications. And on the left-hand side, it talks about the car, driver, for anybody who's looking there, what I'm talking about. I
These are all physics theories. Can you tell us what matter is composed of in your theory? And he got people to list them out. So he went and he actually, after a year's work, only got 20 members to go through all the steps. But we had them. We had 20 members doing this. And what he essentially did then is summarize in each one of these, and I'll just quickly read over. The main claim is 1. What is matter composed of in your, is B, matter composed of in your theory. C, what is the medium of space? And then how is energy propagated? E, what is mass? F, what is gravity? G, what is electric charge? H, what is magnetism? And then they also had to provide us an online access citation to how to find their theory. Okay, so this is what Lloyd did after a year. And I want to highlight something that's important to what David said before about the membership. The goal of the membership is to help each other. Why do we come together as members? Why don't we all do this on our own? Because if we work together, there's synergy in membership. So when somebody contacts me, my goal is not to tell them what to do. My goal is to say, how can I help you? And how can we expand this? And, oh, now that I know what you want to do, here's 4 other people that I know of who are working on it. Contact them directly and so forth. So this, what I was trying to do with Lloyd is to help him follow up on that idea of getting members to produce papers. So I'm going to talk about that in wikis something, but let me go back to the physics forum. What I found out in the past, in a number of occupations that I've had, is that humans are very competitive. And it's not so much this idea that I want to beat the other guy, it's that we can all, it's what I call cooperative competition. You know, in business is set up as a predatory competition like bacteria. You start businesses and they're supposed to eat each other up and only one survives and then they all die because they eat the resources. In competitive cooperation, think of the Olympics. And in fact, the traditional Olympics in Greece, where the outcome had to be measurable against natural science. That is, if we're going to race, you have 5 runners, there's a line out there at 100 meters, whoever gets across the line first wins. It's not like ice dancing, where after people do a bunch of things, a bunch of judges get back and say, well, I'll give this person a 7 and a 4 too. Discus, at the line, throw it, whichever goes the farthest wins. It was easy to determine using natural science how this was done, the javelin and so forth. So we are competitive, but what gets the most out of humans in competition is if we set goals and then we compete against each other like the runners of a race to reach the same goal, but the outcome is measured by the goal, not by my personality or things that I like and what the other person likes. So this competitiveness I've seen applied in many ways. So I said to Lloyd at the conference, what might be fun is just to make a game out of what you're doing. And he said, okay, tell me more, I don't understand how. So this is where I came up with the physics Grand Prix. And the idea of a Grand Prix race is something that most people just know enough about it. Bunch of cars going around the track, crashing, burning up, running, going to the pit, doing all those things. You know enough about it so that it can focus your thinking around an action. And if I say to you, what's the most important thing in the race, I'm going to get the same answer from everybody. First guy over the finish line. First gal over the finish line these days, right? More women getting in the racing, that's great. So, but it's a natural philosophy thing. And let me say that again, Paul, because it goes back to your answering about what's in critical thinking, what's good critical thinking, what's bad critical thinking. In my view, the way this comes about is I never critique the person. Cameron and I go back and forth. He has theories, I have theories, they're different. What's important is when I say to Cameron, stop saying, go back to junior high school, go back and study this. No, no. What is the formula that you're trying to understand? What is the physics we're trying to understand? So he writes it down, I write mine down, I give mine to him, he gives his to me, and we criticize him all up and say, I can't understand this. You know, why'd you write this? He comes back and he says, I can't understand this. So the point is, again, it's the focus on natural philosophy. And why I say that, I don't have the natural philosophy shirt, but it's in here, is that back in the Renaissance period and as we came into the Enlightenment, what people were saying is, if we go to supernatural thinking, the problem is we have no way to grab it. By definition, we're natural. We can't reach that goal directly. We can do it through intuition and other ways, but we cannot bring it here, put it on this table and say, what's this, what's this, what's this? We can't grasp it. But natural philosophy is defined by stuff we can. I can hold this, I can pass it to you, we can pass it around and say, we all held it. Okay, so at least we do that. What color is it? Black, 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 green, red, red, green, black. Okay, we can discuss now how come we're seeing it differently, but we can decide that this is the answer, not people's thinking. So now I'm going to bring it back to the race. The race gives us a focus, only a focus. But what the goal, the whole goal of this, is to get us here and the membership and anybody watching to get interested in these people's theories. So I took each theory. What happened is we got these 12 people to 20 people to go, and then they had to do what David is asking about our personalities to make our profiles. We said, you have to answer every one of these questions. You have to give us an abstract. You have to tell us what the theory's about. In A, you have to say, what is the main claim that sort of identifies this? What's your title? And then you have to tell us, how is matter composed in your theory? Number C, what is the medium of space? You have to describe that for us. And each one of these things, then, once they did that, we said, okay, you're fine. And out of the 20, only 9 took the effort and were willing to fill in all the blanks. Even some are blank. And so I just said, okay, I'll take it. Fine, we'll take it. And then said, let's turn this into a game. So what the game focus here is that we will all be judges. We're going to go along at almost every break, like between talks or lunch, dinner, whatever. I'll hand out one of these forms, and each one of these forms is for a letter. So this form is for the main claim. And what it does is it says, each one of you, it's funny, when we first were going to get everybody to do everything, but we expected 20 people, we were going to have 20 questions, we have 20 theories. If you do the math on that, what do you like? 40,000 different input, we couldn't manage the data. So we simplified it down to say that we'll ask I'm going to be asking each one of you to pick 3 cars. And what does 3 cars mean? If you look next to main claim, you see numbers on the left that match the cars at the top. And at the top, the drivers are the authors, essentially. And then each one of them, I gave a number, and the car, that little diddly graphic car up on the map, has got a number on it. And each one of them matches a person. So what I'm going to be asking you to do is, hello, Duncan.
Hello, Bruce.
How you doing? Is to pick 3 cards. Now, in the process of doing this, I sorted them out on, and if you go back to the front page now, I can just tell you, there are 2 of the theories are straight mainstream. String theory, quarks, and so forth. That's cars 1 and 15. And they're one I just call mainstream, but Ray Redbone's theory in number 15 is pretty similar to that. There are three positron-electron thing is Franklin. His car is number 3. Proton ethers are similar, but photon ethers, 2 cars, 5 and 16. There's 2 car theories, mechanical ethers, 2 and 6, and there's 2 theories that are based on vortexes. Vortexes in either particles or the ether itself. So I would ask you to focus on theories that you believe in mostly, and so take your cars from there and then take somebody else's, but pick 3, and it's up to you, whatever you want, any 3 cars, and stick with those through the whole race. So on every one of these forms that I hand out, write your 3 cars on the top. You'll just see it's straightforward. And then there's 3 groups to answer the questions, and what the questions are, and I'll take the questions off the first one, just get an idea. So question number 1, and this repeats through all of them. Is the description, which you're reading about, is the description clear enough to understand what the person is talking about and how it fits their model? So if I take, for example, I'll take one here, just out of the clear blue. I'll take my own, car number 6, lattice theory. I wrote for the main claim, the universe is composed of a mechanical ether. Moving holes, defects, in the lattice create what we call gravity and mass. So that's my main claim for that theory. So what you would do is you would, when you get this, and we're doing the main claims, you're picking 3 cars. So if you had picked my car and in one of the numbers, you would then rate that on a scale of 1 to 5, with 1 being, is the description clear enough to understand? Well, then you'd give me a 5. If, no, this doesn't make any sense to me, you use 0. Or if in the middle, I sort of think I understand this, and I don't know, I just slap it in the middle too. That's how you do that. Let's go down to ones that get a little more tricky. Question 4 on this one I have this out is, does the new idea move science forward or just create another nightmare? Okay, so then you go back and you read again, all right, he's got mechanical ether, I don't know if I believe that. Holes, this is kind of weird. So then you go back and you say, is this going to move science forward or is it going to be a nightmare? So it depends on your attitude and view of where science is going and where critical thinking is going. You say, okay, so it's a nightmare, so you put a 0 in there for me, right? Or if you think, oh, this is great, you put a 5. So and the questions get more specific, more easy to resolve when you get into how does energy propagate, or what's mass formed of, or what's gravity. Then you can dig a little bit more into the science, and you can grade them a little better. And in that case, I mean, one of the questions, if there's 5 on the front and there's places on the back, I think I got up to 9 questions. And that's easy, just do this and this. So how I expected this to work is, we won't get into one of these until this afternoon. I won't hand one of them out, but in the meantime, I go over lunch or something, just take time and just read through these and get an idea what they're talking about. Pick your 3 cars, read those theories in detail. So number 10, main claim is toroidal vortex. What is matter composed of? Vortex is structured in the ether. What is the medium of space? Isotropic, homogeneous, ultraluminal movement of particles. Okay? So you could decide whether this is going to advance science as that description or not. And as we do that, I'll collect how you've written in the forms, and then based on some algorithms that I made up to try to say which one of these is going to move the car faster, which one of them is going to drive off the track, which one is going to lead that one into crashing into other theories. I'll try to keep these cars going through some kind of motion along the track and in a way that could be amusing, and we'll get to talk about each one of those. And as I said, the way it's amusing, as soon as I was asking for help on the email list, immediately David and I got branded as we were going to cheat and make sure our cars are going to win. And so my disclaimer is we are only honest people. We would never do anything deceitful. We would never do anything that would mislead others or even give ourselves an advantage. So just hang on to your hats as we go through and enjoy it as a game. Again, the purpose, though, is to get you to come back to what David was saying about theories. We have to find a way for anything we've written, how do we communicate it to other people? So this was an exercise in forcing these people to try to think of that. How do I communicate this idea in a way that could go on one of David's wikis? All right, so now I'm bringing this up because we can take a concept that he mentioned and I want to make it concrete, what that means. Wiki comes from, of course, Wikipedia entry. So if you go online for any topic, type it into Wikipedia, you get something listed there. So okay, I'll just pick one. Not Isaac Newton type it in because I've done a lot of that for the science course. So up on the Wikipedia comes Isaac Newton and a whole history. Beautiful, and the Wikipedia is great for this. But the basic theory of the Wikipedia was crowdsourcing, crowd psychology. And the idea is, if you open this Wikipedia article up to the whole world, it will settle down into a truth. All right, so Newton's pretty good, because when people, and another rule of Wikipedia, you can't have your own ideas. I don't know if you knew that. What you're supposed to do as an editor is find a primary reference, summarize the primary reference, and put your summary in there. This is what it was said by Mark Twain when he was commenting on over here. And here, then you reference that down to the citation you pulled it from, so people can go read Mark Twain and make sure you told the truth or if they agreed with it. So Wikipedia, open source, you can only put in primary references. All right, so Newton you can understand pretty easily how that might work. Let's take something more controversial, gravity. You go to the gravity page, and what happens is people who sort of are in good jobs at universities and have time will go there and they will edit it to say what they believe. And if you are a person, I'll just pick anybody at random, named David, I mean that's an easy name to grab onto, goes in there and says, you know, our CNPS doesn't really agree with all these things. I'm going to write down here, well, we have other views of gravity. It might be G particles, and this is what they are. Or it might be ether in this form of mechanical ethers, or it might be magnetism, or it might be positron-electron pairs. What happens is the editors from the mainstream come in and wipe you out overnight. So where it settles down is into a mass psychology, but of people who have control. All right? And to give you an idea on a Wikipedia how bizarre it could come, there is a page on one section in the Bible that gets updated 2,000 times per second. Now nobody can move that fast, but what it means is you've got some 40,000 editors that are looking at this. And as soon as they see some word change over here that somebody's made that they don't like, they come back in and do it. And while you're watching, if you just sit there and click, refresh, 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 you can watch that paragraph jump around. Okay, the CNPS wiki is different. It's not open source. Anybody who's a member or outside could have input to it, but they have to go through a filter. And what the filter is going to do then is to say, and this is the one sample I produced, and this is, which is not concrete at all, but this is the way it's branching out, is it starts out and says, If you go and you look up gravity on the main Wikipedia, this is what it says. Just copy it over. However, there are other viewpoints, and here they are. Ray Gallucci has this idea about this part of gravity, and Ray's article's right there. Bruce has this idea about this there. Duncan has an idea about gravity, it's here. And they're all listed. And it's accessible the same way. So if a person types gravity, pops up Wikipedia, gravity, CNPS, wiki, gravity. So what has that done? It's now combined all these things together. We discuss it in a forum, we yank it out, we create a wiki page. That's where the forum came in. The forum was an organizing tool to get the people with an idea, to publish it there. We all talk about it, to refine it as best we can. Peer review more than we've had in other articles. It's sort of peers, we're helping each other to do this. Once we get it to the form that it's understandable, meaning it gets around the Grand Prix, because the theory's gone through this kind of process where, yeah, there's all these questions, but the question that I keep asking over and over again at the top is this description clear enough to be understood? And once we get the theory told over and over again by many of us to say, yeah, this is clear enough, I understand it, bang, right in Wikipedia, gets published. And all these pieces come together. Okay, so let me see what I talked about. The forum a little bit, the wiki, how this is pulling together. Yeah, so I was trying to put this Grand Prix in context with all the things that David was saying, to give you all an idea that there is some cohesiveness to all these pieces, and they accomplish the mission of the society, and that you're all involved in creating the mission of the society as well as being participants in it. And that's what the forum is. You go to section 9 in the forum, and there's a dialogue about what are we doing and so forth. And you'll see more of the stuff that David's talking about when you're trying to find out, where can I find this in a hurry? Because if you go to the homepage, there's too many things. It's hard to find, but when you go to so when you get down to the forum, we'll get this. I'm getting some coaching from the peanut gallery. We talked about getting away from the mainstream, and I think that's an important thing to realize that we're doing. We used to think, how can I get the mainstream to change? No, that's Gibraltar. We're in a kayak or something. We're not going to move Gibraltar. But there's a whole bunch of kayaks that are headed off into a new ground. That's where we are. We're moving away. Forget the mainstream. We can't beat them. But we want to do it by finding new science, not by just finding disagreement. So I hope that more than one person comes together, helping with their theory and peer review, saying, we've made some discoveries. So in the trial that we're going to have tomorrow night, and you won't be here, it's going to be online, but we're having a science court tomorrow where centrifugal force is going to be stand off against Isaac Newton. And Isaac Newton agreed to come, so he's going to be here. And centrifugal force, and we're going to have the two of them there. But the idea, what I want to demonstrate in that trial is that it's not just arm wrestling with old ideas. New science, breakthrough science is going to come through, and you'll see it in front of your eyes and be part of it, because everybody's going to be dragged into the trial. They don't know it. Forum science court. Okay, so let me call for questions, because
you have this. You can maybe go to.
Oh yeah. I'm just gonna. I'll go up to the Grand Prix. It's right behind you. Don't get so you don't have to move. So what I did is, again give us some focus. This is the map of the racetrack at Monaco. the Grand Prix. Okay, and these numbers are corners, and that's where they have observers looking to see if the cars are going through. Here are the cars, the numbers on the cars, each match the numbers on the sheet. And green flag is up right now, so they're all launched, they're all on the road, they're all headed off there as fast as they can to get around the course. And when you, there are 20 corners and there's about 10 steps. So what I hope to do is take the cars for each step through, you know, a tenth of the course. But as I say, this is just a funny thing, that what I expect is that when you come over and you look for your favorite car, and like Franklin's car, the positron-electron theory car, you know, he gets over here, and then if you come up here and you're saying, I wonder if he's ahead of Bruce's car, you know, the lattice theory car over here, and you find out that all of a sudden Franklin's cars jump way down here, somebody's going to say, what's going on with this, right? And then we're going to have to put Franklin up here on the hot spot and ask him as the driver, what's going on here? In which case, none of you know that this is going to happen, but it's part of the skit, it's part of the game. He would get a chance to describe to you a little bit about the thing that he put into his theory for, let's say, gravity. What is gravity? He'd be able to describe to you a little bit about that piece of gravity. You know, how his positron electrons, which are an ether, create gravity. So this is a focus mostly to give us reasons to do other things. Have little training courses, compare one theory against the other, and see how simple it could be to create a theory to the sufficient form, right? So where we can actually publish it. Okay. Any other questions? Okay. Hope you have a good time with it.